Hello students, here is Shittu, your mathematics teacher. In today's tutorial, we are going to be solving problems on application of differentiation. Then don't forget that this class is brought to you by IOTA Virtual Learning. Okay, so we are going to start with the first question. The question says find the rate at which the area of a circle is changing with respect to its radius. When the radius is 5 centimeter, then we have all these options. So now let's see how we are going to solve this. Find the rate at which the area of a circle is changing. So the main mention of the area of a circle. So you should remember or you recall that the area, okay, is what? Pi r squared. That is, the area of a circle is pi r squared. Now you have to remember that. Now, they now said, let area be equals what? A. Let area be A. Now, if the area is A, so this formula is now going to be A equals pi r squared. Now, find the rate at which the area of a circle is changing with respect to radius, which means that we want to know the derivative of what? Of the area with respect to the radius. This is what we want to know. All right, with respect to radius. So we're going to have this to be the r is the variable we are differentiating. The pi is just a constant. So we're going to have 2r, because these two we have to multiply this, r 2 minus 1. Then we have dA over dr is going to be 2 pi r, because 2 minus 1 is going to be 1, and r to the power of 1 is same thing as r. All right, so from there, the next thing we're going to do, they said when the radius is 5 centimeter, here we are giving the dA over dr at what? At radius to be what? 5 centimeter. So which shows that anywhere we see r here, we're going to put 5 centimeter. We have 2 multiplied by, don't forget, it is multiplication that is 6 between 2 pi and r, multiplied by the r is what? The r is 5. So now from there, we can see that 2 times 5, we're going to have what? We're going to have 10, then pi. So therefore, we have dA over dr to be 10 pi. Okay, and since we have 10 pi from the options here, okay, that is option C, and that is the solution to the problem. The second question we're going to solve, the question says the distance s meter of a particle covers in t seconds is given by s equals 3 over 2t squared minus 3t. Find in ms raised to power minus 2, that is meter per second square, the acceleration. Okay, the meter per second square is the unit for acceleration, this unit of acceleration of the particle. Now here we are given this. I would like you to pause the video, do it yourself, then we can come back and check your result, right, whether it is right or not. Solution. So now let me rewrite this distance they are talking about. The distance is this. Now, the first thing we need to do, because the question said we should find the acceleration, but the first thing we need to do is that we need the velocity before acceleration. So now, to get the velocity is same thing as ds, that is the change in s, which is the distance, over what? Over time, over the change in time. So therefore, we're going to look at ds dt, which is same thing as differentiating these two. We have to multiply this, okay, 3 over 2 t 2 minus 1 minus 3 t 1 minus 1, and here you should know that we are going to have 1 times 3. Are you following? So we have ds dt, which is the velocity, is going to be this 2. We cancel this 2, we have 3t, because 2 minus 1 is same thing as 1, then t to the power of 1 is same thing as t minus what? 3. Because here t, 1 minus 1 will give us 0, then t raised to power 0 is what? Is 1. Understood? That is t raised to power 0. So we're going to have this to be 3t minus 3 into 1, because t raised to power 0 is 1. We're going to have 3t minus what? Minus 3. So that is this is what we get for this velocity. Now the acceleration. The acceleration is going to be d square s all over what? Over dt squared. I mean, this is ds over dt. So we are going to differentiate this again. This one, let me call this equation star. I'm going to differentiate this, okay, to get the acceleration. So it's going to be 3t. The differentiation of 3t is going to be 3. According to what we have here, you can see 3, because you're going to have 3t, 1 times 1, then minus 1. Then if you want to differentiate this one, this will be what? 0, because it's a constant. So we're going to have 1 times 3, we have 3t to the power of 0. So you can see from here, you're going to have what? You're going to have this to be d square s over dt square is going to be 3 multiplied by 1, because the t here, t raised to power 0 is 1. So we're going to have 3. So which is d square s then dt square. So now d square s over dt square, it's same thing as what? Same thing as acceleration. So therefore the acceleration, okay, is 3 meter per second square. So meter per second square, that is our acceleration. Are you getting it now? So looking at the option we have, so we can see that we have option C to be the solution, right? Now we have problem 3. This is essay. This is essay question. The question says the function f of x is given by f of x equals x to the power of 3 minus 3x squared plus 4x plus 1. So the question says find the derivative of f of x with respect to x, then the b, the gradient of f of x at point this. All right, so how are we going to solve this? Okay, now I'm going to write the let f of x be written as y. Okay, so we're going to see that y is going to be the function given to us minus 3x squared, all right, then plus 4x plus 1. So now when they say derivative of f of x, and we've already said the f of x to be what? Y, which means the derivative of y with respect to x. So it means the derivative of y with respect to what? To x. That is dy dx of this. Now dy dx of this is going to be, you multiply this by this, we have 3x squared, you minus 1 from it. 2 times 3, we have 6, minus 1 from 2, we're going to have 1. And the same thing as putting nothing there, that is 6x. Then here, if you differentiate x, is going to give us 1, we have 4. So this is the first thing they ask us to find, which is the derivative. How are you getting now? This is the derivative. So the derivative of the function f of x with respect to x is this, the first thing we are asked to solve. Then the b, the gradient of f of x at point. Now, if we are now assigned a particular value to x, okay, so this dy dx becomes the gradient. That is, the gradient is now going to be dy dx at, but since we are having x here to be the variable, we have the point 2, 5. In the first entry here is what is x, while this is y. But from dy dx we have here, we can see that the function here is function of x. So we are going to pick just these two and neglect the 5. This is going to be 3 into bracket. Anywhere you see x, you put 2. 2 squared minus 6 into 2, then plus 4. So from there, 3 times 4, 3 times 4, all right, because 2 squared will give us 4, minus 6 times 2, we have what? We have 6 times 2 plus 4. Now here, 3 times 4 is 12, minus 6 times 2 is what? Is 12, then plus 4. Now, according to what you have here, so we can see that 12 minus 12 will give us 0, so they will be cancelled. Then we're going to have the gradient to be 4. So therefore, the gradient, okay, of f of x at this point is what? Is 4. And that is the solution to the problem. The fourth question, find the equation of tangent to the curve. We have this curve here. At the point, we have the point here. So how do you find the equation of tangent? So let's see how we are going to do that. We have the solution. So we are given the y to be x to the power of 3 minus 3x plus 2. So this is the function, this is the curve given to us. So how are we going to find the equation of tangent to this curve? Okay, so the equation of tangent is what? Is a straight line. For example, let's say we have a curve. Something like this. So the tangent means a straight line that is touching the curve, okay, at this point here, okay, is touching the curve, okay, at external part like this. So this line is called the tangent, equation of tangent. So we want to know the equation of this line. So that's what they mean by tangent. Now, before we can now get tangent, we need what? We need what we call m, which is the what? Which is gradient. M is what? Is gradient. Are you getting it now? So I know that before we can get the gradient, so it means that we are going to differentiate this. So differentiating this, that is when we can get our tangent. Before we can now what? We can now find the equation of tangent. So just listen attentively so you can see what we are trying to say here. So now it means that you're going to have dy dx is going to be, differentiating this, we're going to have 3x squared minus, differentiating this, we're going to have 3, because 3 times, then you remove 1 from here. So we're going to have, here is going to be 3. And the derivative of constant value is 0, okay? Therefore, we're going to have plus 0 and it's nothing. So we have the derivative dy over dx equals 3x squared minus what? Minus this. But if you want to get the gradient, which is the m, which is the gradient, let me say gradient m, which is the gradient, okay, which is the gradient, is going to be dy dx at, we are given the point x, because it's x we are having here. The point x is what? Is 2, according to what I said in the previous example. So this is going to be 3. Anywhere you see x, replace 2 squared minus 3. So from there you can see that we have m to be 3 times 4. 2 squared is 4. 3 times 4, we have 12 minus 3. So 12 minus 3 is going to give us 9. So this 9 is the gradient. We're not going to stop here. We are looking for the equation of a tangent. So now, since we have 9, which is m, which is the gradient, okay, so now we're going to have what? Recall that the equation of tangent takes the form of y minus y1 equals mx minus x1. Okay, so now this y1 and x1 is this point we have at the point 2, 4. Okay, where x1 is 2 and y1 is what? Is 4. So we are just going to do the replacement. Wherever you see x1 you put 2, wherever you see y1 you put 4. Understood? So from there, what we're going to have next is let me write the equation of tangent again. Mx minus s1. Here x1 is 2, y1 is the second point, which is 4. And m, we've already gotten m to be what? 9. Do you understand? So we have y minus y1 is 4 equals m is 9. X minus x1 is what? Is 2. So try to open the bracket. 9 times this we have 9x. 9 times 2 we have minus what? Minus 18. Are you getting it? So from there we have y equals 9x minus 18. You transpose this to this side, we're going to have plus 4. So you have y equals 9x. So minus 18 plus 4. That will give us minus what? Minus 14. So therefore, this is the required equation, which is the equation of what? Of tangent. So the equation of the tangent is y equals 9x minus 14. And that is going to be the end of this video 2 under the application of differentiation to real life. Thank you so much for watching. Bye bye.